I think we're good to go, and we will wait for more people to join as we progress along the webinar. Thank you very much for those that are connected today for this training session on innovative mass transit options. This is a webinar that is the final one, actually, after the series of webinars we had following the launch of our corner store methodology at Mobilize Your City, which is the Sustainable Urban Mobility Plans Guideline. And I'm going to talk about this a bit more later on. So this is the last session of the training, the training series composed by 4 sessions. We had the launch of the guidelines. Then we had a session about transport modeling, a third session about measure selection and scenario development, and this one that is about innovative mass transit options, in which we will discover uh, different options of public transport systems, and then how to integrate with digital technologies and mobility as a service. So if we can go to the next slide, please. So this is a training developed by Mobilize Your City with the support of our main donors, the European Union, the French and the German governments. And this was a training developed in collaboration with Aegis in the framework of the technical assistance given to Medan in Indonesia in their SUMP development, in their Sustainable Urban Mobility Plan development. If you want to conduct a session as this one, please check the training catalog that we made available in our knowledge platform and get in contact with the Secretariat, and we will provide more information. And if it's pertinent, also support. Next slide, please. So just to provide some general notes on this session is recorded and it will be published in the YouTube channel of Mobilize Your City. And it will also appear in the knowledge platform. So if you don't want to appear in the video, please make sure that your camera is turned off and that your microphone is muted so we don't create disturbances and we allowed a smooth session today. You can include your questions in the chat whenever you want to do so, and then the idea is that I could gather the questions that are typed there, and then I will ask them directly to our speaker. Otherwise, there is some time allocated to questions and answers, and you will be able, if you want to do so, to turn your camera on and unmute your microphone to speak up and ask the question directly to the speaker. Next slide, please. So for today, we have 3 learning objectives, as I was saying before. The first one is about have a clear and unbiased picture of existing urban mass transit modes. So how to know which mass transit option is better in a context rather than other. The second one is understanding critical analysis needed to assess multiple urban mobility mass transit modes. So uh, what is it that I need to consider when selecting one over the other? And the third one is to get to know digital tools to optimize and enlarge service offers and their compatibility in each city. And this has to do on how we can benefit from digital technologies to improve the services and the system in general of mass transit. So next slide, please. So as for the session, we have different sections. The first one that I'm doing now, the welcome and the housekeeping. The second one is we're going to go into the existing urban transport modes around the world. A third section on the main drivers of innovation in public transport. Then we will have a little section to ask questions and then also answer to these questions. And the fifth session, the future must be prepared now. So it has to do with these digital technologies and how to integrate them into mass transit. And the final part in which we will have a little bit more of time to ask questions, provide answers, and then if time allows it also to think about a very brief study case that we prepared for today. So the last thing I'm going to say on the next slide, um, no, sorry, this is not the last thing. I would like to introduce our main speaker today, Maria Teresa Molina. She's a transport planner at Aegis, and she will be leading the presentation today. So she's our expert. She has more than 25 years of experience in transport planning. Her focus is in economy of transport, and she was very involved also in the development of the SUMP in Medan in Indonesia. So she's here today representing the consultant team that's participated in that project. And as I was saying before, the content that you're seeing today was developed in the framework of that sustainable urban mobility plan in Medan. So Maria Teresa, thank you very much for being here with us today. Um, and it's me, Nicolas Cruz. I'm sustainable mobility expert at the Mobilize Your City Secretariat. Following the capacity building activities like these webinars, but also methodological support to the projects, especially in Africa and in Latin America. In the next slide, this is the last thing I'm going to say. As I was saying, this session is part of a series in the framework of the launch of our SUMP guidelines, as that there is the publication you can see on the screen. And I just wanted to say what it is that is special about our guidelines compared to the European guidelines that you might know, the guidelines from ELTIS applying to the European context. So we have an extra step. We have 13 steps as opposed to 12 steps in the European guidelines, and these steps has to do with the preparing a readiness assessment. So when before starting the whole process of developing a sustainable urban mobility plan, the city should actually have like a very deep research and work of gaining a bit of memory of what happened before and see where the city stands in order to kick off the process. The second thing is our SUMPs and Mobilize Your City have a clear orientation towards climate change mitigation and adaptation. So the ultimate objective of all the SUMPs we have in Mobilize Your City is trying to reduce emissions, greenhouse gas emissions, and increase resilience in the cities. The third one that has to do with our session today is to try to make the most of innovation and digital technologies potential, because as paratransit, for example, it's one of our core topics at Mobilize Your City. We see that innovation and digital technologies are a good lever to accelerate this transformation. The fourth one is to establish sustainable mobility observatories for monitoring and evaluation of the SUMPs. And this is to make sure that once the SUMP is finalized, let's say like the policy document is finalized, there are tools to actually follow up on the implementation and that the actions are actually carried out and it's not just a document that was stored in somebody's office. And the fifth one is that the guidelines that you're seeing on the screen are just only part of a robust system of support for cities. So we have methodological support. We also have this kind of activities to increase capacities at the local level. But we also provide technical assistance, advocacy, and many other services we provide to our cities and our partners. So I invite you to visit the publication that was shared in the chat as well. And now, without more saying and taking time from Maria Teresa, I invite you to take the floor. And again, thank you very much for being here with us today.
Thank you, Nicolas. Y- Um, there you go. Uh, so, as Nicolas was saying, we are going to see first what the existing modes are around the world. But we are going to discuss a little bit how do we choose a particular one and what are the forces that transform individual mobility. So traditional modes, you might be familiar with most of these that I'm going to show. The first one is mass rapid transit, which is a high capacity transport system based on rails. It is found in urban areas and in general in big cities. It's the main mode of transport in big capitals, London, Paris, New York. Those are electrically powered trains and operate on an exclusive right of way. They can be underground, elevated, and sometimes, but it's rare, at grade. Um, they never intersect with roads because of their speeds. It would be very dangerous with mm, creating safety hazards. They have high operational abilities and usually they require a heavy infrastructure and complex systems, and therefore they are quite expensive. They can be quite expensive, especially if they are underground. Um, Technical characteristics, the commercial speed can reach up to 40, 60 kilometers per hour. It's rare to reach 60 kilometers per hour, but it's something between that. Uh, a transport capacity can be of up to 70,000 passengers per hour per direction. This is to be a quite heavy system, and the investment costs per kilometer can be between 70 and 130 million million per kilometer. This is this is more or less an average of costs, but of course they can be more expensive, and it depends on how much do you want to build around your system. If you want to do special stations, iconic stations, for example, that can increase the, the cost of the system. A lighter option to metro is what we call light rapid transit. It's also rail-based system or found in urban areas in general in smaller cities like I don't like Vancouver, for example, has light railway systems like these ones. Uh, the operational abilities are lower, so they have, for example, lower speeds, the capacities are lower as well, and the frequencies and operational ranges are lower than those of metro. Um, so the reason for that is because basically they use smaller trains. The platforms are therefore smaller. Uh, Rarely they are underground. So most of the time they are elevated or sometimes at grade, and sometimes there are intersections and they are not uh, fully automated like metros that can be fully automated. The commercial speed is a little bit lower than the speed of metro. It's about between 30 and 35 kilometers per hour. Capacity is about 25,000 passengers per hour and per direction. And the cost, as I said, it's a bit lower than that of metro. So it's between 50 and 100 million dollars per kilometer. Um, there are um, mm, o- other modes that are being implemented in cities as mass transit and have been quite successful, which is what's called the bus rapid transit. Basically, it's a road-based transport system that has dedicated roadways, and they have a priority at intersections. the access to the buses is optimized. So, for example, the ticketing is not on the vehicle but outside the station. So it's similar to the stations that you would have for a light rail transit. Um, the vehicles are usually, until very recently, they were all of the fossil fuel, but the new systems tend to be electrified, and there are new technologies that are being implemented to make sure that mm, fossil fuels are not required. Uh, these systems have high operational abilities, and they are a lot better than conventional bus systems because they have higher speeds. For example, just the fact that they have priority at intersections that allow them to go at faster speed, and the fact that they also have a dedicated right of way. Uh, they can have high passenger capacities and frequencies. For example, at the bottom left, bottom right of the slide, there is an example of a system in Bogota which has been working for 25 years. The vehicles are very long. They can be articulated or bi-articulated, so they have extremely high capacities. Um, they sometimes reach the capacity, the reliability of a railway system with very reduced costs. In terms of technical characteristics, they can reach up 20 to 30 kilometers per hour of speed. Um, the capacity can talk about 6,000 passengers per hour and per direction, and the costs are very low, between 10 and 20 million dollars per kilometer. And well, this one, I'm sure you are all familiar with conventional buses. It's basically a public transport system that is based on roads, on public roads. Most of the time, vehicles are fossil fuels, but it's not the case everywhere. And now there is a lot of innovation in many cities, and transport authorities are starting to use massively electrical vehicles or even gas-powered vehicles. They are the best of most public transport systems because they are very flexible. They can go everywhere, and you don't need a lot of extra investment. So the costs of implementing a system like this are very low, and also the costs of operating it the are lower than the costs of operating a railway system. The inconvenience with these ones are that they are subject to road congestion because they don't have any fully dedicated roadways, and sometimes they even contribute to vehicle congestion. In terms of technical characteristics, well, it depends on the speeds that there are already in the city for cars, but usually the speeds of buses are between 10 and 15 kilometers per hour. This is the commercial speed. We talk of a capacity of about 2,000 to 2,400 passengers per hour and per direction. Of course, this is different for every city, and it depends on the levels of tolerance of every city of each city. So it can be, sometimes it can be more or less. And the costs, well, basically this we are talking here mostly about the costs of buying the buses, the rolling stock, because in terms of infrastructure, you don't need in most cases, you don't need to invest on additional infrastructure unless you want to invest on this on bus stops. So how we choose a mode? Uh, Usually we think of a transport mode as the rolling stock because the image that we have of a transport system is the rolling stock. but in fact, there is a lot of other things that are related. Basically, there is also the systems. So there are uh, all kind of systems related to how we provide information for users, how we operate the system, how we give priority at the intersections. There is the infrastructure that sometimes it's visible, sometimes it's not. When we talk about metro, for example, the infrastructure, it's not very obvious, but because in most cases it's underground, but it's quite heavy infrastructure, and it can be, as I said before, it can be completely segregated, like in the case of metro or light rail, or even bus rapid transit, and it can be at grade, can be elevated or underground. Uh, so, and each mode has some particularities in terms of infrastructure, rolling stock, and system, and there are different uh, concerns for each of them that have to be analyzed. And all this difference between the systems, rolling stock, and infrastructure are what define the operational abilities and the costs of each mode. So uh, all of those have to be taken into account to find out what mode is most suitable for a particular context and for a particular city. Um, so usually when a mode is chosen, there are a lot of criteria that have to be analyzed to decide. And it depends on each city what the priorities are. Usually this is done with the public authorities, with the transport authorities, to define what is it that they have as an objective for their city, what is it that they aim, what are the existing transport problems, and usually there are multi-criteria analysis that are done to define what is the best mode for a particular city. But there is one particular criteria that is key, which is basically the passenger capacity of the system and the commercial speed. Um, so you need to know what the demand is in the city or along a particular corridor to decide what the mode is. And once all those needs are defined, once the objectives are understood by everybody, then the feasibility of the options have to be studied. For a particular city, there can be different options, and for a particular corridor, sometimes it's just not one particular mode that responds to the needs of a particular city, but most of the times you need a fully integrated system that uses a combination of all those modes. And 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 to define exactly what is it that is required for the city, you need to analyze all the different options of combining all those modes and to make a definite choice. But all those modes, most of the time, they they don't allow you to do an end-to-end trip from the very origin to the final destination. So you need to complement that with what's called a last mile accessibility mode. So basically, all those modes that allow you to go from your home to the nearest station, or from the station to your office. Sometimes these modes can be used just for the whole trip, but sometimes they are used in combination with public transport. So we talk about this individual mobility, and we can talk about two different sets of individual mobility modes. The, the owned vehicles, uh, like the most commons are private cars, and motorcycles. But um, more recently, and uh, very these micromobility modes have have been used everywhere in most cities. We are talking about just some cycling or scooters, private scooters, and also, well, we, we cannot forget that we can also walk everywhere. So there, it's what it's called like non-motorized transport. But there are also shared vehicles. In the last few years, many cities have developed these systems of sharing vehicles. The first one is the stationary vehicles, in particular cycles, although it can be also electrical scooters. Um, Carpooling, which is basically the fare of sharing a vehicle between several people. Um, Other free floating share vehicles like scooters that are everywhere, that they don't have a particular station where you pick them up, but they are everywhere. They can be scooters, but they can also be cars. And finally, ride hailing, the fact of using an app to book a vehicle, basically the taxis. Um, these modes can be developed through public and private initiatives, and it is the case in most cases. The shared vehicles or ride hailing have been developed first by private initiatives, and then uh, transport authorities have taken up and have adapted uh, to impose rules for the operation of those services. Um, Sometimes they need adapted infrastructure, like in the case of stationary shared vehicles, like cycling systems. They require that there are stations where you can pick up your bike, and there have to be incentives for the people to use them, and regulatory frameworks so that they encourage people to use them, and encourage the private sector to invest as well. Uh, their development should be complementary to public transport. We are not supposed to encourage the use of private cars um, as a mode for the end-to-end trip, but the idea is that these are promoted as a complementary mode to public transport. And the idea is that we need to reach an environmentally, economically, and socially efficient mode overall. Um, so how this is supposed to work? The idea is to have a mass transit system in a fully integrated system, and with other systems around it that fit that mass transit. So see if mass transit is considered to be a light rail system, for example, there should be also uh, bus lines that fit into that corridor. But there has to be also non-motorized uh, transport, which could be just walking, promoting walking, or just cycling to the stations. But there has to be also different policies and regulatory frameworks around that that improves traffic, that ensures traffic management, to ensure that there is less congestion, for example, that there is institutional strengthening, and that there is travel demand management to reduce the number of trips. The different modes, um, it's sometimes it's a compromise between capacity and accessibility. So we have to try and reach that equilibrium between capacity and accessibility. That's why there has to be an integrated system that improves both. if we see the list that on the screen, the top systems are those ones that have a higher transport capacity, but have lower accessibility. The ones at the bottom have an extremely high accessibility. You can reach everywhere with those, but everywhere in terms of short distances, but you cannot do the full end-to-end trip using those modes. There has to be a complementarity between both. So what happens when we have a fully integrated system that takes all that into account? Basically, we have a coverage of the network that is wider. The passenger travel comfort is improved. The accessibility to those mass transit modes is increased. Uh, we aim to lower the costs for the passengers. There is a seamless transit in the sense that you don't have to do lots of changes of mode to reach your final destination. If you promote a fully integrated system, uh, there is an increase in the willingness to change from from car to public transport systems, and the overall mobility is improved. So so we are going to see now what are the main drivers of innovations. Um, we were we had thought before that we could maybe have a break that, but I'm not sure it's necessary. If anybody needs a break, please let us know, but I'm not sure it's necessary.
I think it's fine for now.
Okay. So we are going to see what the main drivers of innovation are now. So whether with what is called the disruptive technologies in urban transport, what is it that we are trying to achieve by innovating, and what are the challenges in transport innovation? So what are the levers that we can use to trigger and generate innovative mobility? Uh, the, there are three key aspects. The first one is energy consumption. Um, we need we need to develop techniques that are alternative to fossil fuels, and that uh, that generate less environmental impacts. So we need to try and find alternative fuels and new processes for the production and distribution and the use of alternative fuels. But at the same time, we need also regulatory tools. This means to have laws and regulations that have been used in similar contexts to achieve the goals of innovations. Sometimes these regulatory tools can prevent prevent innovation, like in the case of automation of systems. Um, the technology might be there. In the case, for example, of autonomous vehicles, the technology might be there, but if the regulation is not there, we cannot implement those systems. For a few years, the technology has been advancing uh, quite fast, but because the regulatory framework takes a long time to be ready, then we cannot implement those certain types of technology. Um, uh, there are three important technology developments that uh, have been around for a while and are being used uh, in many uh, situations, but in particular in transport, which is the Internet of Things, which is basically the system of objects, processes, and data which are connected to each other via sensors and control remotely using the internet. We are all familiar with this. We all have a mobile phone, and we all do most of everything that we need to do nowadays. We can do it using the Internet of Things. Big data, the utilization of complex data. It's called big data because of the sheer volume of that. Uh, it is available everywhere, and it can be used um, to analyze the existing situation uh, and to generate options to solve solutions, options or solutions to solve problems. Um, and artificial intelligence, which is the computer science, which aims to enable machines to imitate how the brain works. Um, as I said, all of these are being used for in many aspects of daily life, but are being used heavily to innovate in public transport as well. So what is it that we try to achieve when we innovate? Uh, the main objective is to reduce the resources that are necessary for for transport. And the main resources, we can say that they are time and energy. So if we can rationalize these resources, then we can spend less time and less energy for a similar trip. Um, what is it that we call the travel time? Is basically all the time that is spent on doing a trip. So it's not just the time that we spend in a vehicle, but it's also the time that we spend planning that trip, getting the information required, accessing and egressing by foot, by cycle, by car. Actually, the time spent on the vehicle, sometimes we need to do to change vehicles, to change modes. We have to purchase a ticket. So all that time should be reduced, and we have to innovate in terms of those aspects. In terms of energy, the energy is that required and to operate the system, and it can be optimized if we improve the technology and the fuels that we use for that, and we reduce the internalities and externalities. So in here we have to innovate from the point of view of the owner of the system. And when we innovate, we have to take into account both. We have to take into account the innovations, thinking about the time that the user spends on transport, but also the how we optimize the energy use. Um, when we innovate, we can reduce one or multiple costs of transport. Decreasing time and energy allows for saving, not just for the users, but also for the owners. But it can also multiply the improvements for the communities. So usually when we implement a public transport system, uh, we have to do a cost benefit analysis that takes everything into account. So it's a balance between what is it that the costs are. So basically the costs in terms of the time savings for the transport users and the energy savings for the owners, but also the external costs. So basically, or costs or benefits, which are the indirect impact on the community. So there is the reduction of the environmental impacts. So there is less carbon emissions, there are less pollution, there is there might be less noise, and there is an increase in the safety of users on one hand, because the systems that we implement are safer, but also because we reduce the number of private cars in the streets. Um, the idea of improving um, sustainability of the urban transport is going to reducing the external cost of urban transport. So the 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 cost should be zero of the external cost should be zero in terms of we should have we should aim to get nearly zero carbon emissions, air pollution, etc. However, um, sometimes when we uh, look to improve the travel time of users, we can also increase the externalities. Sometimes we have to make sure that when we implement a system, we are not hiding the impacts of that new transport system. And the one important one is the urban landscape impact. For example, there are modes that uh, uh, require a lot of space, and they change completely the city. So we have to take into account that how that system, how the stations, how the infrastructure impact the landscape of the city. We have to make sure that we are not adding additional noise pollution when we implement a system. So what are the challenges of innovating in urban transport? Oh, we can say there are four. The first one are the costs. So as I said, if we talk in terms of time and energy, investment costs are required to implement the infrastructure. Basically, if it's a rail-based system, all the railway stations, we need to buy a new rolling stock. In terms of energy efficiency, we need to do research and development, um, uh, try to find new transport system and vehicles that are more environmentally friendly. We have to find a infrastructure, new infrastructure for production of energy, new energy distribution networks, and new fueling infrastructure. One, as I was saying before, there is an important challenge, which is the regulatory framework. Um, the fact that there is new technologies implying new regulations, and sometimes um, I think it's difficult to know what the impact of a new technology is going to be. So it takes a while to understand the impact of that technology and to try and implement an adapted regulatory framework. Sometimes speeds have to be limited, safety regulations have to be implemented. Um, One particular case is the case of electric scooters that go everywhere. At the beginning, when they started to be implemented in cities, there was no regulatory framework that said that at way that they could circulate and what would be the speed that they had to reach. But after a few months or years of implementation, public authorities realized that it was dangerous to let those scooters go everywhere without any regulation. So now the cities are starting to implement um, rules so that speeds are respected and they can only um, ride on particular roads or in particular spaces dedicated to them. And and sometimes it requires a coherent taxation framework as well. Um, the other challenge is market acceptance. Sometimes people are just reluctant to change mode if people are used to the convenience of their own private car. It's difficult to explain to them that it's that the new system that is being implemented is going to be not just comfortable but safe as well, and it's going to be efficient. So it takes a while to make people understand all that. Um, Sometimes the infrastructure is invasive, so sometimes it's difficult um, to convince people to let them build a station near where the place they live, for example, or uh, letting pass a heavy infrastructure just over their homes. Um, the fact that there is new regulation, people are find it difficult to accept as well that there is a new regulation, and potentially higher costs. Not always is the case. The idea is that for the user, the costs should be lower. Otherwise, it would be impossible to make them shift modes. But people are afraid that it's going to be more expensive. Sometimes people are so used to using their car or their motorcycle that they don't think of the overall cost of having that they are paying for the trip, but they just concentrate on the fact that that if they take a public transport, they have to pay a particular fare. So sometimes people are reluctant to just shift. Um, there has to be a shift to more energy efficient modes, and users are expecting that we innovate in terms of that. People are more conscious of the impact on the planet. So people are expecting that there are modes that are more energy efficient and more environmentally friendly. And in terms of the long-term vision, sometimes it's difficult to understand that the results are going to be seen later. With public transport, the investments have to be done and the results might be seen just in a few years. So sometimes especially the first few years of implementation of a particular system, it's difficult to tell whether the system is working or not. You have to wait for a few years to see to see the impact. So sometimes it's difficult to accept that. And it's the same for energy. The implementation of any new innovations in terms of energy are not seen immediately. Uh, Now, in terms of, um, did you want to say something, Nicola? No, sorry. In terms of the modes that can be welcome as a city of the future. Yes, this was a there is a short question and answer session.
Yes,
If
before passing to the next session, there are some questions already on the chat. So this is a question that I was wondering myself because, of course, I would say the main driver to select one or other option of mass transit is the demand that there is in the corridor. So, like, we implement a corridor of a metro line or a BRT line in order to cover a demand that there is in place. But what about thinking the other way around? And it's like, what if we provide this service to impact some other elements in the urban environment? So, for example, Franco Jauregui, he was talking about uh, transit-oriented development. So we provide transport options in order to densify an area in the city or to impact property prices, capture land value, increase walkability in a certain place. Um, so how would you say that this the instinct approach would change the way we prefer some transit modes over others?
well, I guess I guess that's another way of thinking about innovation, transit oriented development. What I was talking in here is more about um, in general is about places where there is already established cities that are already established, where there is a public transport system already established. But of course, I think one way of innovating as well is doing transit oriented development. I think it's a big bet. You don't know whether it's going to work or not, and usually public authorities are more concentrated on trying to resolve the problems that they have today. Related to public transport, rather than trying to anticipate future problems. And I mean, it would be ideal if we could anticipate the problems, but in most cases, we are just trying to solve what already exists. So we are trying to create that public transport systems for the people who need them, who need it to make today. In most cities, there are needs for public transport, but I think that it had to be. We should do both at the same time. We should be, on one hand, we should be thinking of resolving the transport problems that we have today, but at the same time trying to anticipate so that there are not those problems in the future. So I think they go hand in hand. I think we shouldn't forget that we should be planning to prevent transport problems in the future.
Thank you, Maria Teresa, for your answer. And indeed, I think this is a good question, specifically for Mobilize Your City contexts that are so diverse. And in some cities, of course, there is already a good provision of public transport, but in some others, there is a lot to do. And especially with these processes of developing sustainable urban mobility plans, it's a good moment to think about the city we want to have and put in place these tools and elements when considering mass transit options. I'm gonna ask another question. So just to bring back a bit the sustainable urban mobility plan cycle, uh, in which you have this diagnosis, then you prepare the vision and the scenarios, and then you propose measures. Um, and I would say that to think about mass transit, then you would go directly to the measures in which you will say, in this corridor, we might need a high capacity line of mass transit. But then how far do you go when you select the measures when you're preparing a SUMP? Because I know, like, at the end, like, for example, if you go for a metro line or a LRT or a BRT, I mean, the prefeasibility study will define which option is better. But then on the sum, how far you go? Do you put, we need just mass transit, or do you already select the mode when you're preparing your sum?
Well, in the SUMP, no, it is we don't go to any detail level of study. So in the SUMP, you usually define a series of policies that cover all the modes. So it doesn't concentrate only on public transport, but it has to be integrated. So it takes everything into account. So what do we do about private cars? What do we do about public transport? And then when we do public transport, we think as an integrated system. So there has to be a trunk mode. There have to be feeder modes. There have to be modes that allow the accessibility to those feeders and to the main mode. Um, and it could be usually when you do the sum, usually there is a transport model that tells you what the demand is expected, and you can have an idea of what is the best mode that at least that responds to that demand. But sometimes it's not that easy to define to decide between some of them. So at some level, you can provide different options. You can say in here this is adapted for a metro line, and in here it's adapted for a light rail or a BRT, because between light rail and BRT there is always a bit of intersection. It's difficult to define between both of them. And in general, uh, you say more or less where there should be feeder lines, for example, and what other modes are to be proposed. But in the some it doesn't go as far as to say exactly on this corridor the answer is this one. It gives some ideas of where it should be going, but then after that there has to be a feasibility study that compares the different options. But there is a more detailed demand study, and as I was saying before, there is a multi-criteria analysis that decides that takes into account everything that is important for the city, for the public authority, and for all the stakeholders. So usually there is an analysis of the capacity against the demand, but there is also technical constraints. Sometimes even if we want to do a light rail, we just don't have the room to do it, or we just don't have the money to do it. Resources are limited, so sometimes it's a problem of having that budget for the system. Or I mean, sometimes there is just a, a river that we cannot cross unless there is a big investment. So there are lots of technical constraints that have to be taken into account as well. So that comes later on, not within the SUMP, but then afterwards when we decide to do a feasibility study. And usually these feasibility studies are done separately for each line. So we don't do a feasibility study for the whole SUMP, but usually it's separately, line by line, or just for a few at the same time.
Thank you, Maria Teresa. And we got another question on the chat, but I'm going to link my second question with this last part that you mentioned about the technical constraints when you're deciding one option over the other. And it's because, of course, we have this list, like the criteria you were mentioning, that are very attached to the technical side of the thing, how like what the capacity is, the topography of the corridor, the practices of users, like the availability to shift of mode. But then there is another dimension that can play, especially because we're talking about very big infrastructure projects, and it's the political side of selecting one part of the other. And I don't know if you have any insights on how also because this webinar is meant to be for practitioners on urban mobility, so not decision makers, but the ones that are daily working on these issues, how we can strengthen our technical arguments to influence that political will that at the end plays a key role when selecting an infrastructure project of mass transit.
Yeah. Well, it is tricky because sometimes cities just want to do a particular system. They want to implement a particular system, uh, and it's difficult. Sometimes there are difficult technical discussions with public authorities to try and find the best solution. The best solution, I mean, is the one that costs less and that gives the most benefits. And resources are limited. So some, yeah, sometimes it is very difficult to try and explain that. Um, Sometimes some authorities would like to extend a light rail line, for example, but it's difficult to justify it technically. Just there is not the demand for it. It's just too expensive. So there are in some cities the conversation is easier because there is a framework defined by governments. There is some guidance that says we only invest on that if the benefits outweigh the costs, and this is the threshold. So this is where I would start investing. For other cities, when there is not this guidance is more difficult because you can play with what you have seen in other cities. So that's it's very important that there is that there is a guideline so that it makes life easier for the consultant that is doing the study. The consultant. usually has experience working on other cities and has seen guidelines from other countries. So the consultant is always going to try and ensure that the system that is being proposed is the one that is most economically profitable for the city. There, it might be hard to explain that to certain authorities. So one way that one thing that we do usually is use examples from other cities, and yeah, just try to be thorough when in studies. Try to list absolutely all the inconvenience of choosing a particular mode. And a consultant, we have to be neutral in the sense that we are not there to sell a particular technology. We are there to try and find the best solution for a particular problem of a particular city.
Okay. So benchmarking and clear guidelines on how to
I,
choose your modes of transport.
yes, benchmarking
Um,
is relatively easy. With the Internet of Things, we can now do benchmarking quite easily, but guidelines are take a long time. I mean, it's
okay.
getting easier. More and more cities are implementing guidelines, and the good thing is that we can always use the guidelines from other cities, things that we know that work in other countries. We can try to implement it, and most public authorities receive well those guidelines when we show them what is done and what has worked on other cities. They receive it quite well.
Okay. Thank you very much. I think we can then answer our last question and then we can continue the session. And this question is related to the use of big data, but I would also say digital solutions for, but specifically for non-motorized transport to increase capacity of the mass transit corridors. Do you have any ideas, experience, or insights on how these solutions that are not related to public transport, but that are more like feeders with non-motorized transport can actually work to increase the demand of public transport?
Well, there is a lot of research. One particular data that is being used for a few years now is the data collected from mobile phones. So it's difficult to get the data. Because usually we have to pay for that data. Usually there is more than one provider in each city. So sometimes because resources are limited, we cannot buy the data from all the different providers. But sometimes we just try to buy the data from one of the providers, and we hope that it covers most of the trips. I mean, and statistically, it works. It is a big sample, so it should work. So for a few years, we have been using this big data in this sense. It's more at research level. I mean, there is so much information, and every day we are inundated with new data. So it is constant research, and constantly we are trying to find ways of using that data. For the moment. There are cities where this is explored. I mean, there are many models that already try to implement things like that. Uh, more in terms of knowing how people use the existing public transport systems today, rather than non-motorized modes. But there is in terms of research, there is, for example, multi-agent modeling. This is activity-based modeling. Those are things that the objective is basically to try to understand how people make decisions in terms of transport, try to understand the whole trip, not just from from the station, from the initial station to the final one, but trying to understand how they decide everything uh, they do in the terms all the activities that they do during the day and how they decide what mode that they are going to use and which route, and things like that. So there is research, and hopefully it's going to help with the models that we are building now. But for now, it's mostly research.
Okay. And I think what you just mentioned, it's a good transition between the topic before and the next section, sorry, about the digitalization and mass and mobility as a service. So I think if you're fine, then we can continue now with the rest of the presentation.
Okay. So I'm gonna talk a little bit about digitalization and mass and mobility as a service, about some technologies that are well known but can be used in a different way, and some other innovations that um, we don't know if they are going to get anywhere. It's between a challenge and a utopia. So how to make use of new tools and opportunities? Basically, in terms of the operator side, we need to make sure that there is real-time routing. Um, we need to automatize that routing uh, to make sure that the operator can contact vehicles all the time, and then there is a constant link between the infrastructure and the operator, so everything has to be fully connected. Um, there has to be uh, on-demand. There might be demand dynamic mobility offers. So for that, the operator should be able to characterize the demand, compute how to answer to that demand, and communicate the result to that involved vehicle. So we need to understand where the demand, where the demand is in real time, and how we can respond to that demand at the same time. And big data, th- knowing that there is all this data available every day and it multiplies every single day, then we need to understand how we can use that data and how we can uh, read it and analyze it to improve our systems. From the passenger side as well, we need to use that big data to make sure that passengers can uh, uh, tell us what is it that they need, and what is it that they expect from transport. In terms of route choice and itinerary, we have to optimize route choices and itineraries for the passenger. And for that, the easiest way of doing it is through an intermodal user interface to offer real-time resilient itineraries. We should be able to include fare integration so that people don't have to pay for all the steps or the trip, and we, we we can use mobility as a service, right? Basically a unique platform that combines all these elements needed by the user. So what's mobility as a service? It is basically the integration of different forms of transport services in a single on a single platform. Usually, this is done through an application that applies that provides access to mobility. It's a single payment channel, and there are different various forms of public transport, of transport, so you can access bus, metro, private operators that you can uh, call a cab or use a ride-sharing service, and all that just done through a single application. So the idea is that with your application, you choose your origin and your destination. and everything is done for you. It tells you what's the best option, and you can even pay and have real-time information about the vehicles that are going to provide that service. So basically, it's a unique platform that has ticketing. So basically, you can pay on the platform. You have conveyed fares, so that you pay for the full origin to destination trip. You validate that payment. Um, it is a multimodal information system, so you have it is basically a journey planner with also real-time information, and it offers all services. So you can book a cycle, you can book a bus, you can use those disruptive technologies like electric scooters, or just all those new technologies that are being used recently. Public transport, you can uh, reserve a spot for parking, carpooling, rent a car, etc. So everything that has to do with transport, you can do it through this platform. Um, and we know that many cities have systems for some of those things, but the idea of mobility as a service, a platform that offers everything, is not very common. This is not provided everywhere, and it's not provided in many cities. So let's talk about new solutions that can be implemented, uh, which are being implemented as well today, but are relatively new. Uh, the first one is personal rapid transit. So these are basically small automated vehicles that operate on a network of dedicated gateways. They provide point-to-point on-demand transport services, and they are used for fairly light, time fragmented, but redundant amount of mobility. So this usually you can see them in, for example, in airports. So the one at the bottom right is the one in Heathrow Airport. It goes from Terminal 5 to a car park. It has 3 stations, and on a dedicated guideway of 4 kilometers. Um, the capacity of these systems is about 1,000 passengers per day. The one at the top is in Abu Dhabi, in Masdar City. It goes from the Masdar Institute of Science and Technology and has only 2 stations. So it's a guideway of about 1.2 kilometers, and the capacity is quite small. So in general, the capacity of these pods is more or less the capacity of a private car. It's about between 4 or 6 people. So usually when you take one of these, you are on your own, or you are with your family. In the case of the one for Heathrow Airport, you have a space to put your bags, for example, when you leave for the airport. In terms of technical characteristics, they have a commercial speed of between 20 and 30 kilometers per hour, and the capacity of them is about 2,000 passengers per hour per direction. As I as it's shown on the slide, both of the ones that are in this example in Abu Dhabi and in Heathrow, they are right now they are moving around 1,000 passengers per day, and the maximum travel distance is about 30 kilometers. Um, other solutions that are becoming a bit more common, and for the time being they are a bit restricted by the regulation, are group rapid transit systems. So they are similar in the sense they are that they are autonomous as well, but they don't need to be segregated. So they can even run within the normal circulation, within the normal traffic. So there has to be a regulation to make sure that there are no accidents. But the technology is there already. The technical characteristics, they can reach between 15 and 25 kilometers per hour. The maximum transport capacity is about 4,500 persons per hour per direction, and the maximum travel distance is between 10 and 15 kilometers. Of this, there are a few systems in Europe. There are quite a few in France as well. The one at the top is basically is in the Netherlands in Rotterdam. It goes from the from one metro station to a business park, and it has 5 stations. It has a dedicated guideway, although as I said, it's not necessary. Of the length of the guideway is 1.8 kilometers, and it crosses traffic at 5 intersections. Um, the capacity of these boats is about 24 passengers, so it's a relatively big vehicle, and it moves right now. It moves between 1,000 and 2,000 passengers per day. And the vehicles are the way it works is that people interact with them like you do with an elevator. Basically, you open the vehicle with a button, and then you get on like you would get on an elevator. The one at the bottom is in Paris. This is in Bois de Vincennes. It goes from one and Castle, a touristic spot, and it has 8 stations that it runs over 6 kilometers. They also have a dedicated guideway, um, and it crosses a highly frequented intersection. The capacity of these ones is a little bit smaller than that of the other ones in Rotterdam. It has about 11 passengers, and the commercial speed is about 13 kilometers per hour. As I said, the commercial speed can be higher in the sense that the technology is there. It can be up to 25 kilometers per hour. The vehicles are designed to reach higher speeds, but the regulation doesn't allow them to go over a certain speed. In particular, when there is no dedicated guideway, the regulation limits the speed. In France, it limits the speed to 8 kilometers per hour. Um, there are solutions that already exist, but can be used in a different way. One one example is cable cars. Until very recently, cable cars were just thought as modes found in touristic areas, or just to do some sightseeing, or just to, for example, for skiing, to reach places that are very difficult to reach otherwise, but only recently have been used as a public transport mode. So there are now quite a few examples of cities that are implementing cable cars as a public transport mode. So these are basically some kind of cars that are hauled above the ground and by one or more cables. They are relevant for point-to-point transport crossing a constraint, like a natural obstacle, like a river, for example, or just a very steep a mountain. The infrastructure is very simple. It only requires some pylons and some cables and stations. So the cost of this is usually a lot lower than the cost of implementing a bus rapid transit or a light rail. The commercial speed is between 20 and 25 kilometers per hour. The maximum transport capacity is up to 5,000 passengers per hour per direction. And there is not really, we don't know, I don't know if if anywhere they have reached the maximum travel distance, but the distance between uh, uh, can be very long. So that there is not really a limitation on the distance that you can reach. So we can explore that uh, for all cities and all obstacles. The examples that are shown there, the first one is in La Paz in Bolivia, which is uh, quite with lots of hills, a city with lots of hills. There are 36 stations, so there are 10 cable cars. So it is a fully developed network of cable cars, and each of the gondolas can transport up to 10 people. The commercial speed is not that low; it's actually 22 kilometers per hour, which is a lot higher than the speed usually reached by buses. These ones, these lines in Bolivia have a maximal transport capacity of between 3,000 and 4,000 people. At the bottom, the example is Brest's cable car in France. The cable car crosses a coastal river. It has 420 meters long and with an elevation of 70 meters. Uh, the, the, the cabins are quite big. It had the capacity for 60 people. So you see there is for each city, different options can be considered with very different capacities. The commercial speed is about 14 kilometers per hour, and this one in Brest moves around 1,200 people per hour. Other solutions based on systems that already exist but can be used in a different way are river shuttles. Uh, Again, river shuttles in many cities are seen as a touristic attraction and as modes that are used for the weekends, but they can be used also for commuting. So basically, it's a water shuttle is a public transport system that uses that can be used in different water bodies, so lakes, rivers, on the sea, and they follow a predefined route and schedule between piers. In most cases, it already exists. So it's the infrastructure that has to be built is very light. Basically, you need the piers and the docks. And the commercial speed of this is between 6 and 12 kilometers per hour, and the maximum capacity is up to 500 passengers per hour per direction. The maximum travel distance is up to 12 kilometers. Um, at the top, it shows an example in Bordeaux, in France. The fleet it has two catamarans, which have a capacity of about 65 people each, and the line has about 6,000 kilometers with 5 stops. It actually moves quite a few people, 240,000 people per year, and um, the tickets that are used in this system are intermodal. So basically, you can use the ticket for that, or you can use it on the bus as well, which is quite handy. You don't need to buy a different ticket for that. The example in Sweden, in Stockholm, they have a fleet of 24 vessels, and they have 4 lines, for urban lines and 28 metropolitan lines that covers the whole archipelago of Stockholm. They have about 21 stops and 30 kilometers of urban lines. This moves a lot of people. It's 3.9 million passengers per year only on the urban lines. And as with the case of Bordeaux, it uses intermodal tickets. So usually you can either take the ferry or take the bus with the same fare. So those are modes that already exist that can be used in a different way. And then there are some modes that have been investigated recently, for a few years already now, and that we expect that at some point will be used. We hope that can be used, but we don't know if they are going to work on or not. So one of the examples is the Hyperloop, which is basically a system of boats that are powered by induction motors in a lower pressure sealed tube, uh, which reduces air resistance. This was launched in about 10 years ago. The idea was launched about 10 years ago by Elon Musk. I mean, it's based on other ideas by people before, but Elon Musk really made a lot of publicity about 10 years ago, and he started a contest to see who could design a Hyperloop the fastest and things like that. So there was a lot of people talking about Hyperloop a few years ago. The University of Lausanne built a prototype to do tests to see what the distance and speed um, can be reached. But they are hoping, according to the theory, they are hoping that at some point the capacity that can be reached, it's extremely high. It's about 1,000 kilometers per hour, which is extremely high considering that a high-speed train now reaches only about 300 kilometers per hour. So according to the theory, a hyperloop should reach about 1,000 kilometers per hour. We are not there yet at all. The maximum capacity that has been reached recently with these systems is about 170 kilometers per hour. So right now we are far from that objective of reaching 1,000 kilometers per hour. So we don't know what's going to happen with this. It sounds extremely expensive, and for the time being, we don't know if it's going to be as promised, to have all the advantages that are promised. So for now, this is more utopia than reality. uh, the one on the right, this is probably a little bit more realistic. This is the research is more advanced. These are sky taxis. So basically, these are remotely or autonomously piloted flying vehicles used for urban air mobility. And uh, they can reach a speed of about 100 kilometers per hour. The capacity is quite small. Because the idea is that it is like a taxi, so it's up to 6 people, and the maximum travel distance is between 25 and 100 per kilometers. As I said, the research in here is more developed. There are prototypes that reach up to 80 kilometers per hour. So this might happen relatively soon. At least in Dubai, they are talking about releasing some system sky taxis that are going uh, to to be implemented by 2026. So we'll see what happens, but these are things that might happen in the future. These are quite specific uses, so this is not going to replace a mass transport system, but it is where the innovation is going. It is where the new technologies are going. Well, I think that's it. That's all that I had to show you, so that we can now go to questions.
Yes, Maria Teresa, thank you very much. And I think this last part is quite interesting because at the end, I think most of all work on urban transport in general, but we never imagined that these solutions at some point might become the solutions we're going to deal with in a daily basis, especially if we talk about these flying cabs and like the Hyperloop. Um, well, the Hyperloop, I'm not sure it's suited for urban context, but the Sky Taxi for sure is. I have a question regarding what you mentioned, um, and it's specifically about the first solutions that you presented, this personal rapid transit. And it's because, of course, the way it works, it's very similar, like, for example, to a bus line, like a regular bus line. My question is related to why to prefer these low capacity vehicles over bigger buses, for example. Why to have an autonomous car able to carry only people instead of having a big bus
Yeah.
with a
Well,
60 passenger capacity?
Well, I don't think the one replaces the other. These are these are systems that are built for specific objectives. So if you want to move a lot of people efficiently and fast, you have to think of systems that have high capacity. So you start with buses, then you move to bus rapid transit, then you move to light rail, then you move to metro. These private rapid transit modes, they don't have as much capacity, and we saw and if you talk with the people who promote those systems, they might tell you that the capacity is extremely high. In practice, when you analyze how do you operate those systems, you realize that actually it's not that easy, and that you have to wait for one vehicle, that you cannot send one vehicle after another. So sometimes it's unrealistic what the manufacturer says. So we have to keep in mind that PRT has lower capacity than buses, and the objective is not to replace transit or buses with these systems. In general, these systems, mm, PRT or these group rapid transit systems, we use them when when the capacity required is lower, when the distance is not that long, because there is a bit of investment. I mean, they require a guideway in most cases. So there is, I mean, it doesn't have to be a very heavy infrastructure investment, because the highway might be just something to make sure that people don't get into the guideway, but it only requires a very light infrastructure, but still it is an investment. So it's usually for short distances, and for very specific usages. I showed the one that I showed in Heathrow, that is excellent, because people only go from the station, from the airport to the parking site, so it works really well. So you just go when you leave the airport, then you just it's the elevator system again. You just press a button, you just wait for the car to come, you get on. And sometimes one of the things that limit the capacity is that people don't like traveling with others. So when you call for a PRT vehicle, you expect to be alone, and unless there is a long queue behind you, you just take one car for yourself. So it is a vehicle that has capacity for 4, 5, 6 people, and you just take one, so that limits the capacity. So the advantage is that it's innovative, it's modern, the image of the system is quite nice, and people sometimes just like the idea of having privacy. So people like the idea of being in a vehicle on their own, and they are fast as well, and the fact that they are on demand, so you don't need to provide a service all the time. So the vehicles are only used when they are required, but they are not adapted. Definitely they are not adapted for commuting. For example, if you need to move a lot of people at peak hours, you need to have vehicles that have a higher capacity. You need basically you need mostly vehicles with a high capacity, at least buses for that. So it doesn't replace PRT or GRT doesn't replace a high capacity transport.
Yes, and now that you elaborate your answer, I think because now I see the cities where it was implemented, and maybe there are cities in which car use is very well established, and so people might be interested also in using these low capacity services as opposed to mass transit that might be a bit strange for them. Um, Thank you very much. There is a question on the chat. I mean, it's not a question, more like a comment. But I think it's interesting because you were showing that there are different types of innovation. So it doesn't have to do necessarily with technology improvements, but also like new uses we give to the technologies that they are already in place. Um, and in this case, Nicola is talking about this innovation about the creation of express bicycle networks. I don't know, Nicola, if you want to take the floor and maybe elaborate a bit more on your comment yourself.
Thank you. I will try. Just I think that in some of our cities we don't need driverless paths or hyperloop trains. It is not the question, but it is more the way we can extend the capacities of the mass transit and probably the non-motorized transportation like pedestrian or cycling or the other one can be one of the solutions. And an innovation consists in improve the possibility for better implementation by people on the short distances, for example, or medium distances. And with the in Lyon, the metropole of Lyon implement a whole network that gives better a better support and better security for that kind of mobility.
Yes, no, I agree definitely. The idea was to show here what is being done in terms of new technologies and the fact that there is new information available and there is a lot of research that can be used. But I agree completely. Innovating doesn't necessarily mean implementing something absolutely new, but we can just rethink what already exists and make it better. Um, and it's true that I don't think we are going to use anytime soon a hyperloop or the sky taxis, and especially we are not going to replace mass transit with that because the objectives of each system are different. But yeah, innovation doesn't necessarily mean just looking for absolutely new things, but we can just rethink the things that already exist.
Thank you, Maria Teresa. And I have a last question. If anyone else wants to participate, please share your ideas and your comments. But um, specifically talking about the cable cars and and in the Latin American region, let's say they're not new. They're a mode of transport that's been in place for a couple of years now, and more cities are implementing their cable car systems in their own contexts. Um, the first question related to it is, why do you think we still say it's an innovative way of transport when it's actually something that has been in place for years now? And the second is, um, you mentioned that it's cheaper compared to other transport alternatives, but maybe I'm mistaken, but of what I've heard is that there is a lot of opposition from the political uh, power and cities because it might be more expensive related to the infrastructure, also because the places where these systems are might be also more difficult, like in topography or in accessibility. So just if you could clarify this issue of the cost with the cable cars.
Yeah, well, the two questions: why we think it's innovative. The system is not it's not an innovative. The system exists, has existed for a while. But initially, cable car were never thought as a transit system for commuting. Most of the places where cable cars were used particularly for for tourism, for example, for skiing or just for sightseeing. I mean, in London, the first cable car that was built in London a few years ago, just basically for sightseeing. So it's something that so some people use it for commuting, but most people just use it because they want to see the city from the cable car. Um, in other cities, and has been the case. But over the last few years, now people have thought that it can be used as actually a public transport system used for commuting, and it's true that it's been a few years now. I mean, there are many examples like we show the network in Bolivia. So the innovation is more thinking. Cable car could be a solution for public transport, because until recently it wasn't thought like that. I mean, if you had seen a presentation about public transport solutions a few years back, you wouldn't see cable car anywhere. Cable car wasn't thought as a public transport solution. Now it is more and more, and it is. Right now, there are quite a few cities that are exploring the possibility, and these are particularly cities which are where the topography is quite difficult, as you were saying, like La Paz, or the example that I was showing, Brest, where it's basically to pass over a river. But there are many other cities where right now we are studying that. Um, and in terms of costs, well, if we compare the costs with the cost of, for example, light rapid transit, I mean, the difference is cost is quite important. The infrastructure required for cable car is basically the stations and the pylons, and that's it. So I mean, there has to be a detailed study to say how much it would cost for a particular case, and it depends on how much the public authority has, how many resources that they have, and how much they are willing to spend on a particular system. It might be more expensive than bus, for example, but because for buses, you just buy the rolling stock, and that's it. You don't need to put if you don't want to, you don't need to put the stops. You just need a signal that says the stop is here, or things like that. So there are solutions that are very, very low cost, and in that case, we would have to put a cable between light rail and bus, for example. But I think it would be very far from the cost of light rail. So it has to be analyzed, and as I said, the this is usually a multi-criteria analysis, so you don't make decisions based on one single criterion, but you need to evaluate all the other criteria. So you need to make sure that the capacity of the system is right, that the costs are right, that the technical constraints are right, that the people are willing to accept a system like that. I mean, one of the first things that we do when we do a cable car study is analyze whether people would be willing to to use a cable car system, because sometimes people are afraid of taking an elevated mode. That they think, what if it gets stuck in the middle, how I'm going to get off. So people that might be reluctant to use it. So one of the first things that we do is try to gather that interest and that willingness to use the system. So there are many things into play. It's not just the cost, but well, that's our role as consultants. Try to show the public authorities what are all the advantages and the convenience of each system, and what's the most adapted to the particular case that they have.
Mhm. Yes, thank you very much for your answer. And I do think that it has to do mostly with the conditions of the area where you're going to implement these cable cars, and also the demand, because it's like very easy to imagine that the cable car will reach the capacity that any other mode of mass transit could reach, like even if it's like a light train, for sure it will have more capacity than a cable car. I don't know what's the situation in La Paz, but it will also depend on the speed, like the how close the stations are, how many stops they have, and stuff. So thank you very much, Maria Teresa, again for being here with us today. We don't have any other question, and we are about 12. So I think it's a good time to close the webinar. It was very, very interesting. And I hope people that stayed during the long webinar learned about these mass transit options and the interlinkages with innovation and digital technologies. Once again, Maria Teresa, thank you very much for being there. We will send a follow-up email with all the information about the webinar, the recording, but also the slides that you saw today. And please keep tuned with the newsletter of Mobilize Your City, so you will get there all the invitations to future webinars and access to all the publications that we're preparing this year for you. So thanks again for staying for these 2 hours with us, and I wish you a nice rest of the day.